do we really use only 10% of our brain? And is the universe infinite? Remember that scene in Lucy where Scarlett Johansson unlocks 100% of her brain and suddenly becomes a superhuman computer goddess? Yeah, that whole "we only use 10% of our brain" thing, total myth. It's one of the most popular science misconceptions ever, that somewhere inside us lies a hidden superpower, waiting to be unlocked. But here's the truth. We use almost every part of our brain, every single day. Modern brain scans show that even when you're chilling on the couch, your neurons are firing all over the place, processing sounds, maintaining balance, storing memories, managing temperature, and a dozen other things you're not even aware of. So no, you're not sitting on a 90% brain upgrade. You're already running at full power. All right, that's one myth down. Now let's go bigger, way bigger. Because if the brain isn't infinite, what about the universe? You might think that's a simple yes or no question, but here's the twist. Scientists still don't know whether the universe is infinite or not, and they might never know. Here's how we got here. Back in ancient Greece, guys like Aristotle and Euclid didn't really think about infinity as a real thing. Fast forward to the Renaissance. Copernicus realized the stars went far beyond our solar system. Then, in California, at the Mount Wilson Observatory, Edwin Hubble studied a faint glow in the sky and realized that nebula wasn't part of our galaxy. It was another galaxy, just like ours, unimaginably far away. And that discovery changed everything. Later, a Russian mathematician named Alexander Friedman, using Einstein's theory of relativity, suggested something crazy. The universe isn't static, it's expanding. His ideas inspired what we now call the Big Bang Theory, the moment everything began. But if the universe had a beginning, can it really be infinite? Maybe not infinite, but unbounded. Think of it like this. Time and space stretch, but they still have an origin. We even know the universe's approximate age, about 13.8 billion years. We calculated that from the color and brightness of the oldest stars, and later confirmed it with the Hubble Space Telescope, launched in 1990. So when we look through a telescope, we can only see about 14 billion light years away, because that's how far light has traveled since the Big Bang. Beyond that, it's literally invisible. The light hasn't had time to reach us yet. But that horizon is expanding, just like the universe itself, meaning that over time, we'll be able to see more of the cosmos. If it ever ends, that is. Imagine you're on a ship in the middle of an endless ocean. No map, no land in sight. You don't know where the shore is, or if it even exists. That's us, floating in space, looking for the edge of everything. So, is the universe infinite? We can't say for sure. But the search, that's what keeps science moving forward. And that's baby science. Is it dangerous to swim right after eating? You've probably heard this one. Don't go swimming right after you eat. You'll get cramps and drown. It's the rule that's ruined countless summer days for kids around the world. And in Cuba, parents make their kids wait 3 whole hours after lunch before they're allowed back in the water. The logic behind this myth sounds convincing. After eating, your body sends extra blood to your stomach to help digest food. That's true. That's also why you feel sleepy after a big meal. Your brain's getting a little less blood flow. But does that mean your muscles suddenly run out of oxygen and cramp up? Not really. There's actually zero scientific evidence that anyone has ever drowned because they swam after eating. In fact, professional swimmers often grab a snack right before a race to get an energy boost. Sure, if you've just crushed half a pound of greasy barbecue, you probably won't set any Olympic records. But going for a swim? Totally fine. So no, your sandwich won't drag you to the bottom of the pool. What are those little floaters in your eyes? Ever looked up at the sky and noticed tiny squiggly things floating around in your vision? No, you're not hallucinating. And no, they're not actual bugs. Those little shapes are called floaters, and they're basically shadows inside your eyes. Here's what's really happening. Your eyeball is filled with a clear, jelly-like substance called the vitreous humor. It helps keep your eye round and your retina in place. Over time, some of the collagen fibers in that gel can clump together or break apart. Those clumps block a bit of light, casting tiny shadows on your retina. And that's what you see drifting around when you look at something bright, like the sky or a white wall. They move when you move your eyes because, well, they're literally floating in there. Floaters are super common, especially if you're nearsighted, older, or spend a lot of time staring at screens. And the good news, they're usually completely harmless. So next time you spot one, don't freak out. That's just your eyes jelly doing jelly things. And that's baby science for you. Why does the bottom of a bottle break when you hit it? Here's a weird one. Ever seen someone smack the top of a glass bottle and boom, the bottom just shatters off? Looks like magic, right? But it's actually pure physics. When you hit the top of a bottle filled with water, the whole bottle moves downward really fast. But the water inside can't keep up. It's just a tiny bit slower to move. And because water can't really be compressed or stretched, that sudden gap near the bottom creates tons of tiny vacuum bubbles. They collapse almost instantly, with enough force to crack the glass from the inside. It's called cavitation, and it's the same effect that can actually damage ship propellers underwater. Pretty wild for a party trick, huh? And if you're thinking about trying it, maybe don't, because it only works with still water. Soda or beer, totally safe. All that dissolved gas fills the gaps before they can implode. So yeah, a tap on top and physics does the rest. And that's baby science for you. Can you survive falling with a piano if you jump right before you hit the ground? All right, this one's legendary, and somehow the most popular question ever. If you're falling with a piano, can you jump right before you hit the ground to save yourself? The short answer, absolutely not. You and the piano are both falling at the exact same acceleration, thanks to gravity. That means you're both picking up speed together, and both have about the same air resistance. For a full-sized grand piano, that's a terminal velocity of around 50 meters per second, or about 110 miles per hour. Now, unless you're the Hulk and can jump at the speed of a race car, your little hop won't do much. If your jump adds about 3 meters per second, congratulations, you're now hitting the ground at 170 kilometers per hour instead of 180. Huge improvement, right? So yeah, jumping at the last second doesn't work, unless you're a raindrop. Raindrops have a terminal velocity of just 5 to 8 meters per second. No matter how high they fall, they always land softly. Moral of the story? Don't fall off buildings with pianos. Go swim after lunch instead. Just skip the beer, because that physics trick won't work there either. And that's baby science for you.